We have learned about zeros with quadratics. So remember that the x-intercepts can be found when f of x is equal to 0. I'll highlight that. The zero product property can be applied when a polynomial is in factored form. And then these values will represent the zeros of the function. Okay, so these ones are already factored for you. If you remember with quadratics, you had to factor them and then set equal to 0. These ones will already be factored for you, which is what's nice. So it's been pretty simple. Okay, number 1, it says find the zeros. And it looks like I need to scroll down a little bit because I didn't give myself enough space for number 2. So let me scroll. Okay. Looking at number 1, it says, so 3, x minus 4, x minus 1, and 2x minus 1. So you have a GCF out in front. I'm not going to bother with that. But then I set my zeros, or my factors equal to 0. So I would start with this one. X minus 4 equals 0. To solve this baby little equation, what would I do? Add 4. This is so simple. So x is 4. Good job, everyone. Okay, there's 1. And carry on. Next one. X minus 1 equals 0. I set that equal to 0 I solve by adding 1, and I get 1. Lastly, 2x minus 1 equals 0. Okay, this one's a little bit more complicated. You would add the 1, so I'm not going to show all the work, and then you divide by 2. What is it? 1/2. There you go. Okay, so you have your 3 zeros. I'm going to go ahead and, this is going to be called what we call a sign chart, okay? So on Delta Math, you're going to do it today as well. Essentially, it's the same thing as what you do on the x-axis when you have a graph. What is my smallest zero here, please? 1/2, yep. Mr. Kaiser. 1/2. And then would come 1, and then 4. All right, we'll deal with that more in a second. Let's go ahead and figure out what's the end behavior, because that'll be determined whether it's even or odd, positive or negative, and I really need to write this down on the whiteboard today so you have it. Okay, look for your, this is LC, so it stands for leading coefficient. That's like your line leader. What is it? See it out in front, the 3? It's just what you see first, 3. So, sorry, back of the original polynomial. So this is positive or negative? Positive. Leading coefficient is positive, so the polynomial is positive. The degree, okay, this is kind of like what we did yesterday with the monomials. Remember, we had to add up the exponents? Same thing here. Problem is, you actually don't see any exponents at all. You can close it for now. So on all of these factors, you don't see an exponent, which means it has an exponent of 1. So can you write in little 1s like this, okay? This is the first power, so is x minus 1, so is 2x minus 1. So when I want to get my degree, because if I were to multiply this whole thing out, which we'll do more of next week, I would get x to the 3rd, because it's 1 plus 1 plus 1. You add your exponents when you multiply, so it's a degree of 3, which is odd. Okay, odds are opposite. They go opposite ways. So odd positive, my right hand goes up. That's the one that takes the sign. Odd positive is like this. Go down, up. So you will not get Desmos actually on your test. I let you use it on the stuff from Tuesday. If I made you do something like mins and maxes, increasing, decreasing, I would give you a graph that's done. But here, you should be able to do this with your brain. Okay, now we're going to complete the sign chart. What this tells you is that on the furthest left side of the graph, it's going down. It's going down to, where's it headed? Negative infinity. Okay, and on the furthest right side of the graph, it's going up to positive infinity. So you see I put a negative sign and a positive sign. We'll talk about what you do in between when we talk about multiplicity, but for now, that's good, okay? Questions right now? All right, so it'll be factored. You set equal to 0. You get the zeros. To figure out the end behavior, you have to know whether it's positive or negative, even or odd. So look at the next one. We've got, looks like 3 factors. Your GCF out in front. Anything that has an x you have to set it equal to 0. So because you have an x there for that first term, this is negative 2x equals 0. If you divide by negative 2, you get 0. Anytime you have an x out in front, it's going to be 0. So there's the first one. So it's not, you don't add 2. Okay, this guy, x plus 3, you get minus 3, right? You negative 3. And then your last one, ignore the exponent for now. You would get, subtract 2, you get negative 2. Okay, which one is the smallest? Negative 3. So that's the one you'll put first on your number line. Over here, negative 3, then negative 2, and 0. We're kind of space them out a little bit. We're not going to be super accurate. Okay, let's find our leading coefficient. So your line leader out in front of the function. It's a negative 2. So since my leading coefficient is negative, we know that's going to impact the end behavior. Let's see, the degree is, you see an exponent of 2. It's not the highest exponent because they're all side by side. You have to add them up. So x the first. So out here in front, you have a 1. Come on. Oh, it's not writing. Go. There you go. And an x plus 3 has a 1. So if I add all those up, 1 plus 1 plus 2, degree of 4, it's even. Even, negative. Show me with your fingers or your hands, your pointers. What do they do? Even, negative. Odd is opposite. Is this odd? No, evens go the same direction. So it's down, down. Oh my goodness. Like sometimes it works and sometimes it doesn't. Down, down. Quit. There you go. Okay, so that means that the furthest left side of the graph is going to negative infinity, and so is the furthest right. Okay, the only other thing we're talking about today is multiplicity, which is literally just what exponents do the factors have. Super simple. Multiplicity is determined by the exponent associated with that 0, so we'll scroll in just a second. Exponent associated with that 0. So, for example, this is wrong, not 14. In example 2, the one that's right above, the multiplicity of x is equal to negative 2 is 2. Do you see how on the last one we just did, x plus 2 has an exponent of 2? So then we'd say it has a multiplicity of 2, because that means that there's 2 parentheses of x plus 2. In that case, x equals negative 2 is a repeated root because there would be 2 of them. All right, if the multiplicity is even, we have to do evens and odds, so many things. So 2, 4, 6, etc. Then the graph will bounce or bounces at that 0. That means it'll quickly touch the axis and turn around. If the multiplicity is odd, then the graph crosses at that 0. So if you look at this little picture over here, here's what it means by bouncing. It goes down, up. And then over here, this one crosses, meaning it literally crosses through. So even roots, if there's an even exponent on your factor, it's going to go whoop. If it's odd, it's going to cross right through the axis, the x-axis. Okay, so same exact type of thing, except then you have to determine if it's bouncing or crossing. We're making a complete sign chart, which is exactly what you'll do on Delta Math today. Pro tip for you, don't try and do Delta Math without writing things down. It's not going to go well for you. You notice how much work we do to write this down so we actually know what's happening. You should do the same thing on your assignment today. Okay, find the zeros of the polynomial, give their multiplicity, use the multiplicity to decide if it bounces or crosses, so the effect. starting with the zeros. Okay, the first one is just x. X is equal to 0. So not very complicated here. X equals 0. What exponent is on that factor? It's a 2. And so that is, I'm going to write out, 2, so even. Evens will bounce. I know this is so strange, but that means that there's 2 of them, and I promise that's what they do. Okay. The next factor is this one, 2x minus 1. So 2x minus 1 equals 0. You have to imagine you would add the 1 and then divide by 2. You can write out all the work if you need to, but most of us can probably do it in our head. It's 1/2, okay? What exponent is on that one? Because you don't see it. It's a 1. So you can write it in. There will also be a 1 on the x plus 5. So that means my multiplicity is 1, which is odd, which means it's going to cross at 1/2. And then the last one is x plus 5. X plus 5 equals 0. You subtract the 5 and you get -5 for your 0. Look back at the equation. The exponent on that one is invisible, but it's 1. Odd. So if you don't see an exponent, it's a 1. It's gonna cross. Okay, the smallest one here is -5. Obviously, you have to make sure they go in order. So -5, and then you have all the way over here a 0 and 1/2. You have to know the end behavior in order to fill out the sign chart. So this is where, seriously, write it down. The leading coefficient, what's the line leader? What number is in the very front? 1. You don't see it, but it's a 1. Yeah. So 1. 1 is positive, right? What about the degree? It is 2 plus 1 plus 1. Add them up. 4. So even. Even positive. Odds are opposite. Evens go the same direction. So what does even positive do? Show me. Up. That's the easy one. I feel like evens are a lot easier, right? It's odds that really get me. Up. So on the furthest left side of the graph, it's going to infinity and beyond, right? Positive infinity. On the furthest right side, like outside the zeros, positive infinity. And this is where it's going to get weird. Ready? We're going to actually do the effects. So we're doing like mini graphing today, and tomorrow we'll do a full graphing. Let's start with -5, right? Because we're working left to right. At -5, it says cross. So just watch what I do right now. I'm literally just going to say it's going to cross over. It's going to cross from positive into negative because it's going to go below the x-axis. So this would now be negative. What's it do at 0? The effect is bounce, meaning that it's going to stay on that side. So it was negative. You're going to do like a little whoop. It's going to go up, and it's going to bounce at 0, and it's going to stay there. So that means it's still negative. And you also know, and this kind of just checks your work for you at this step, at 1/2, you know it's going to cross back up, and it's going to be in positive. So if you do the end behavior, that has to come first, and then you'll fill in like the effects. So can you, with the people at your table, please find out for me what are the 2 zeros on number 4? What's their multiplicity? How they behave? Do the chart, basically, okay? And then we'll do the rest. You can do it. Two. Oh, whoops, sorry. Wrong thing. Hold on. so I think that's right. Yeah. +1, -4. Okay, the -2 out in front does not have an x, which means that you don't set that one equal to 0. It's the leading coefficient, but it's not one of your factors that you're going to solve. So you should have, it's going to bounce at 1, cross at 2. Remember, evens always go the same direction, so it was on that side, it's going to bounce back up and go on the same side. Okay, go ahead and just plot these on your number line thingy, right? It doesn't have to be perfect, so -4 over here, 1 over there, close enough. We are going to figure out the end behavior really quick. What is the leading coefficient? Pretty obvious. -2, that's negative. So since it's negative, you know at some point it's going down. Let's figure out the degree. You need to take both of these, 2 and the 3, and you add them up. 2 plus 3 gets you degree of 5. So you can't take the highest one because you have things multiplied together. So degree is 5, which is odd. Odd, negative. Right hand goes down, odd is opposite. So you know how the graph is going to end. You have positive infinity on the left side, negative infinity on the right side, and we know how it behaves. What's it do at -4? Crosses. It crosses down and makes this go down to negative, and at 1, it's going to bounce, which makes sense. That's the only way it would stay negative. I know it's a little strange. Tomorrow we'll graph the whole thing.